welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. In this problem statement, a pentagonal pyramid, 25 sides of base and 50 axis length, rests on HP on one of its slant edges. Draw the projections of the pyramid when the axis is inclined to VP at 45 degrees. So here we can understand that the initial resting condition of the pyramid is not given, but however, the second condition, that is, it is resting on one of its slant edges, is clearly stated. So we can rest the pyramid on its slant edge only when it is initially resting on one of its corner. Only then the pyramid can be tilted in such a way that it is resting on one of its slant edges in the second position. So this is the first conclusion. Next thing is, with respect to the VP, it is the axis which is inclined. And however, the word appears to be inclined to VP is not mentioned here. So since we are going to consider the parameter, that is the axis, which has changed its length from the first position to the second position, it is a beta angle problem. So now we'll see how the solution could be drafted for this. So let us begin with drawing the XY line of thickness 0.18 mm. So now let us draw a line of any arbitrary length and annotate the line as X and Y, and also the reference planes as VP and HP. So now we will draw the top view of the pentagonal pyramid. So for that, let us select a line of thickness 0.50 mm. So let us initially draw the pyramid. 25, the angle is 72, followed by 25 and the angle of inclination is 72 into 2. Next, 25 is the edge length and the angle of inclination is 72 into 3, followed by 25 and the angle of inclination is 72 into 4. So now we shall select the pentagon and rotate this as per the required condition. So for that, we will select the rotate option, select the corner and the edge opposite to that and the midpoint of that particular opposite edge. So now rotate this in such a way that that particular edge is making an angle of 90 degrees. So this is the resting condition. So we'll just move this using the move option, ensure the copy is off, and then this completes the base of the pyramid. So now we need to draw the triangular faces. So for that, let me select the line option. So from the corner to the opposite edge midpoint, draw a line. Similarly, repeat this step for all the other corners. So from this corner, the opposite edge is here, join to the midpoint. From this corner, the opposite edge is here, join to the midpoint. So now we require only the triangular faces and the other lines could be trimmed. So use your trim option. So this line can also be trimmed. So from this corner, let us try to draw the diagonal so that we get the triangular face. Just join to this point. So this completes the top view of the pyramid. Now let us annotate this. So we have got the pyramid which is resting on one of its corner A, followed by the corner B, corner C, corner D and corner E. So this is the apex and also the center of the base of the pyramid. So O1 and next O. So these are the apex and the center point of the base of the pyramid. So now we shall use the projection lines to draw the front view of the pyramid. So let us draw the projection line from each of the corners. Also from C and D, from the point O. So just unselect the midpoint option so that the midpoints of the projection lines are not disturbing us for the further constructions. So now let us draw the front view. So let us select a line of thickness 0.50 mm, connect the endpoints of each of these projection lines. This completes the base of the pyramid, and from the axis point, we shall select a line of thickness 0.13 mm and then a chain line and draw the axis which is equal to 50 mm as per the problem statement. So from the apex, join the end point of each of the projections to get the slant triangular faces. So with this we complete the front view of the pentagonal pyramid resting on one of its corners. So now we'll annotate this. So this is the apex O dash, and this is the axis originating point from the base of the pyramid. So this is O1 dash. And similarly here this is the corner A dash which is visible to the observer, and here it is C dash, and inside the bracket D dash. And also here it is B dash, and inside the bracket E dash. So this completes the front view of the pentagonal pyramid. So now the condition is it is resting on one of its slant edges, and that edge is O dash and A dash. So now let us select the front view of the pyramid after having made this a rigid set. So how to make the rigid set is explained in the previous videos. So follow the same steps to make this a rigid set. So now I'm selecting the front view of the pyramid along with the annotations, and then I'll select the move option and just ensure the copy is on, and keeping A dash as the reference point, I'm going to move this pyramid towards the right hand side of the XY line. Now let me use the rotate option. So the first point of rotation is O dash, the second point of rotation is A dash. So we have to ensure that it is resting on the HP. So for that we'll just reselect the points. So select the rotate option, select A dash as the first point and O dash as the second point, and then place this in such a way that it is resting on one of its slant edges. Use the move option, and then keeping A dash, just drag this so that we have got sufficient place to complete the third position, and ensure all the annotations with respect to the front view are above the XY line. So this completes the second condition in which the pentagonal pyramid is resting on one of its slant edges. To get the top view, let us draw the projections. So select the line of thickness 0.13. So from O dash, draw a vertical projection line. Similarly from C and D, draw the projection line. From the axis point O, draw a projection line. Then from point A, draw the projection line, and also from the point B and E. So we'll just keep the annotations outside the base so that they're visible correctly and they're not being overlapped by any of the projection lines. So now we'll complete the top view. So for that, let us draw the horizontal projections now. So from point A until it is meeting the point O, because O and A will lie on the same line. Similarly from B, it is intersecting here, and then C, it is intersecting here. From D, it is intersecting here. Okay, so now we have got all the points of intersection. So now let us complete the top view. So let us select the line option. Select a line of thickness 0.50 mm. So we'll begin with the point A. So for the observer, the corner A is the farthest point. So with this in mind, so now let us see which all should be the dotted. So from corner A, we have to first connect the corner E and B, which is here. And then from the corner E, we have to connect the corner D. So the projection of D is here. And similarly from corner B, we have to connect the endpoint C, and then finally connect C and D. So this is the base of the pyramid which is observed by the observer. So from each of these edges, now let us try to draw the slant edges. From each of these corners, try to draw the slant edges. So from the end point, connect it to the apex O. And as I told, A is the farthest corner point. So from A to O dash, it will be the dotted line. So use the trim option to trim this projection line beneath this dotted line so that the dotted line is visible clearly. And also make this a separate entity so that when we move this to the next position, we are getting the point O1 dash distinctively. So this completes the top view of the pentagonal pyramid when it is inclined in such a way that it is resting on one of its slant edges. We shall annotate. So this is the apex O, followed by the corner C and the corner D, and then the corner B, the corner A, and the corner E. So now we need to construct the beta angle for this. So for that, let us just use the distance between option and measure the axis length of the first position, which is 50. So this is the point O1 and this is the point O. So here the axis length is 46.01. So we have not annotated the point O1 here. So this is the point O1. So from the projection of O, it is here. So it is O1. So you can just see that the axis line is distinct. It should not be a continuous line or else you'll not be getting this point O1 for the next position. So use this as a broken line, that is A to O1 and then from O1 to O. Okay, so you do not have to show this as axis line. It is understood that the edge line is overlapping on the axis line. So now we'll see how to construct the beta angle for this. So first we'll take up a line of thickness 0.13. Let it be a continuous line. And from any arbitrary point on this line, let us draw the initial length of the axis, which is 50 mm, incline at an angle of given angle of 45 degrees. So the angle will be minus 45. So from the end point of this line, let us draw the locus line. So from the end point of this line, draw the locus line. So we will annotate this. So this is the point O dash or the O, and this is the point O1, correct? So this is the locus of O1. So now we have to take the arc by center point, and keeping O as the arc center point, let us try to cut an arc which is having the radii equal to 46.01, and then try to draw an arc and let that arc intersect the locus of O1. So from the point of intersection, let us try to join this back to O and then measure the angle. So initially this is 45 degrees, which is the given angle phi, and then this is the angle 50 degrees, which is the beta angle. So now we are going to consider a line which is inclined at an angle of 50 degrees to the VP. So it appears to be inclined at an angle of 50 degrees. So draw a line of any arbitrary line, but the angle of inclination will be 50. So use the angle between and measure. So this is the angle 50 degrees. So on this 50-degree line, we are going to incline this axis of the pyramid. So select this pyramid, make it a rigid set, and then move it in such a way that the axis is overlapping on the 50-degree line. So select all the annotations. So I'm just skipping the step to make this a rigid set in order to reduce the length of the video. You can just refer to the other videos how to make it a rigid set. So now let us select the move option, ensure the copy is on. So now let me select the point O as the reference point and place it on the 50-degree line. Select the rotate option, ensure the copy is off from O to O1, rotate this until it is inclined on this 50-degree line. So this completes the second or the third position. So now we need to draw the front view. So for that, let us select the line option of thickness 0.13. Let us draw this projection line from C dash D dash from O1 dash. So from O, the projection point will be on the XY line only. So from A, this is also there on the XY line. And then go for the next corner, that is B. So B is here. Next, we have got the corner C. So almost C and B will overlap, but C is here. And then we have got the corner D. D will again somewhat overlap with the corner A. Next, we have got the corner E, and the projection line will be intersecting here. So now we have to use the zoom option here because we have got two different lines. So use the trim option first. Let us trim the lines which is not required for us. So we have got the A here, and next we have got the point O here. Okay, so we have not drawn the projection from O1. So let us consider the point O1 and then intersect that with the O1. Use the trim option. So this completes the set of intersection of the projection lines. So now let us consider the line option again of thickness 0.50. So now let us start from the point A. The point A is here, and this will be connected to the point O, that is the apex, correct? And then also we have to connect A to the point B. So B is here. So you can just see that the angle is not exactly 90. So please make it 90 degrees. Okay, so from the corner A, it has to move to the corner B. Then from B, it has to move to the corner C. C to D, D to E, and E to A. And draw all the other outer edges, connecting it to the apex. So from this point, that is E, and also the farthest corner point D, we are going to have the hidden edges. So select the dotted lines. The base of the pyramid will be completely visible. So these two will be the hidden lines. So now we'll just try to draw the axis line. So this completes the front view of the pyramid. So you can just see that the pyramid is inclined on one of its slant edges. So we will annotate. So this is O dash, and this is A dash, and this is B dash, and this is E dash, this is C dash, this is D dash. Okay, so The corner E dash is here. This is D dash. And this is C dash while B dash is here. So we have to just swap these. So this is the corner B dash and this is the corner C dash. And then the axis O1 dash. So if you are asked to measure the length of the axis in the final position, use the distance between and measure the length of O1 dash to O dash. So this is the length of the axis in its final position. So with this we complete the problem. So you can use the leader option to draw the direction of the projection lines. So with this, we complete the construction. So just to summarize, we have got a pentagon pyramid resting on one of its corners. So only when it is resting on one of its corner, it can be tilted in such a way that it is resting on one of its slant edges. So that is why when the second condition is told that it is resting on one of its slant edges on the HP, we have taken the first condition to be resting on one of its corner. And then he tells that the axis is inclined to VP at 45 degrees. So since the word appears to be is not used, we have constructed the beta angle, which is found to be 50 degrees. So now the axis appears to be inclined at an angle of 50 degrees in its third position. And then we have drawn the projection lines and also completed the front view of the pentagon. As you can see here, it is